U.S. Navy's second Ford-class supercarrier, USS John F. Kennedy, is now 50% complete as per shipbuilder Huntington Ignalls. The midpoint in construction is reached 14 months earlier when compared to USS Gerald R. Ford due to the modular approach in construction. Ford-class supercarriers are being built to replace some of the United States Navy's existing Nimitz-class carriers. The first ship of this class is Gerald R. Ford. Nimitz-class carriers have been the face of the U.S. Navy and have enabled power projection far off from the U.S. homeland. USS Nimitz, lead ship of Nimitz-class, was commissioned in 1975. The Nimitz-class has been able to accommodate many new technologies over the decades. But the Nimitz design has now reached its threshold, and this is where Ford-class comes in. USS John F. Kennedy will utilize the latest technological advances and incorporate major improvements over the Nimitz-class. With USS John F. Kennedy, the U.S. Navy will have 2 state-of-the-art supercarriers with another 3 in the pipeline. In this video, Defense Updates analyzes why USS John F. Kennedy will be the worst nightmare for Russia and China. Let's get started. Nimitz-class supercarriers got planes moving for takeoff using steam-actuated catapults. The system required a lot of steam piping, a large condensate return, and tons of fresh water. They also have a lot of maintenance issues. Plus, with steam actuation, the majority of the force is being transferred to the airplane at the beginning of the stroke in a jolt. This puts stress on an airframe and thus reduces the lifespan of the expensive planes. USS John F. Kennedy will use the Electromagnetic Aircraft Launch System, EMALS. The system uses a linear introduction motor with an electric current to generate a magnetic field. That field then propels a carriage down a track. Since the power delivery is linear, it negates the deficiencies of a steam catapult and is more suitable for future aircraft and drones like MQ-25 Stingray tanker drone. To know more, check out the video on the above card. 4 of these EMALS will be present. 2 will be at the bow with the other 2 at the port side, enabling simultaneous launch of 4 aircrafts. American Nimitz aircraft carriers, the French Charles de Gaulle, the Russian Kuznetsov, the Brazilian Sao Paulo, the Chinese Liaoning, and Indian Vikramaditya uses hydraulic arresting system, which is a dated system and suitable for only traditional carrier-based aircraft. USS John F. Kennedy will be fitted with Advanced Arresting Gear, AAG. AAG is capable of working with all current and projected future carrier-based aircraft, from the lightest unmanned aerial vehicles to the heaviest manned fighters. The heart of any aircraft carriers are the nuclear reactors, which provide the required power. The Ford class has newly designed reactors. 2 Bechtel A-1B nuclear reactors will be installed on USS John F. Kennedy. Each one of these are capable of producing 300 megawatts of electricity, triple the 100 megawatts of each Nimitz-class vessel. The huge power supply provides for the legroom required for future expansions, like introducing laser guns and electromagnetic railguns. USS Military has been working on these 2 technologies for some time now. USS John F. Kennedy will have an integrated active electronically scanned array search and tracking and SPY 3 radar system. The Dualband radar, DBR, uses a multi-tier dual-band tracker, which consists of a local X-band tracker, a local S-band tracker, and a central tracker. The central tracker merges the 2 signals to provide a comprehensive situational awareness. The X-band tracker is optimized for low latency to support its mission of providing defense against fast, low-flying missiles, while the S-band tracker is optimized for large area coverage. This new system has no moving parts, therefore minimizes maintenance and manning requirements. USS John F. Kennedy has a newly designed deck. It has 3 aircraft elevators that are more efficient when compared to the 4 in Nimitz-class supercarriers. Reduction in one aircraft elevator has freed up space, which will enable faster maneuvering of aircraft in the deck. The island is also smaller and farther aft than the Nimitz-class supercarriers. With this, space for flight deck operations and aircraft maintenance is increased. Ford-class design has implemented automation in a big way, which will result in solid gains in operational efficiency. USS John F. Kennedy will be capable of generating 30% more flight missions per day than Nimitz-class carriers. This will make the supercarrier a deadly adversary.
Thanks for watching. Subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your feedback in the comment section. This will help us improve.